Welcome to this new episode and video on my Arduino Mega2560 connected through SPI and I2C with this Arduino Uno. Some electronics here on this breadboard and more electronics on this breadboard. Connected to fischertechnik, mechatronics and two motors. Last time I tried to get some stuff working and not with all the success that I wanted. It's all, well, on this side it is pulse width modulation. Well, this one is controlled by pulse width modulation from the Uno. This one and this one and this one are controlled by the Mega2560, and for safety reasons they are controlled also by transistor circuits. And there is the problem. This one is positively connected, is working. This one is working. This one is not, and this one is not quite as I had hoped. This one is continuously working, but this one isn't working at all. So to find out why and how, this one is straight connected to the whole circuit and that doesn't work. So right now I am going to connect it the same way as that motor is connected, and let's see if this one is working in exactly the same way, and it is not. It's not working at all. So the question is also, is that motor working at all? For that I will connect it to actually here, but I have to twist the wire to keep all the wires together. And now let's take this one and put it straight to the wire it is getting its signal from, and even that does not make it work. So is there a signal anyway? That remains to be seen. So I will need to probe the signal on the oscilloscope and then see whatever happens. Last thing I did last time was replacing the wires by more solid wires, more robust wires, but that obviously didn't help. So let's take a further look at the wiring and the circuit, and maybe and probably the code as well, and see how it can be done. So right now the whole thing is the oscilloscope is set to I2C, so let's change this for a bit to pulse width modulation, and activate channel 3. And then measure the line, the wire where the signal should be, which is here. It has some kind of signal. Let me stabilize the whole signal by putting it to ground. Then again, then change the right. This looks like some kind of whatever signal it is. how about the other line? Because this line is specifically meant for this motor, but the other resistor behind this see, and when I now right, see, this looks like pulse modulation. So, if this looks indeed like pulse modulation, then how is the rest set up? This is output 2, and this is the other one. And they are using output values. That is true. They are using output values, and output values are defined right here. Sensor value, and then this series of events. Not straight values then. Looking at output. That's quite remarkable. Now it goes on again. So the output is maximum, but that would already be determined from the large plus and the very small situation here. The larger the upper line, the larger the top, the faster the whole system is, the faster the signal. And going back here, it's quite obvious that it is something very different. So this signal is coming from, let's get circuit. Oh, and of course this one, because I need this. And this is coming from pin 4. And pin 4 is here. So what does pin 4 do actually? And look, out pin 4, 253. So why is that different than the other one, which is to pin 7, and pin 7 is 251. So they're all the same, or supposed to be the same. 251, 252, not much of a difference. So what's wrong with this signal? Another thing is, of course, that this one has 3 inductors, this one has just 1, but I am now measuring in front of the inductors and not after it. So let me change that signal. Right, and I will have to, let's see, that is this signal going to 4 that I have to change, and I will take output value 2, which is half speed. So I will take, I want to see what value that is. Oh, that's strange, by the way. Okay, this will be output value 2 as well. This is all with 4. And this is all with 6. Yeah, this way it is better understandable. So now I of course have to find out the process. Six, 8, 9, 6 and 6, 8, 9, 7. Kill. When that happens, and it's terminated. So now I can select the proper port, select the proper port, and go. Everything falls quiet. Well, everything that is controlled by the Mega2560 falls quiet. It's done. So I can go again. There we go. And what signal do we see? Not exactly what I like to see. Yeah, the only thing that I can see is that the period is in half, but this is not what I expect with pulse modulation. But I have to correct myself immediately because oh no, it is on the correct spot. Now how does it behave on the correct way? Aha, see, this is what it needs. This is the correct signal that I want. Pulse modulation, but does it run? For that, move here. Does it run? No way does it run. So despite measuring, no, that's not good. Well, the motor, I have to check the motor then, because this one, Mr. Chain, is doing exactly the same, it is exactly the same type of motor. So that casts doubt on the functionality of the motor. So the test for this motor is quite simple. Using this power controller, this one goes off and this one goes on, and then the question is what will happen. Switching it on. Enough said. And the other way around is the same thing. So this does prove the motor does work. No doubt about that one. Alright. So back to the other signal, also modulated. Which doesn't do a thing. Giving the question, why? I can think of a lot, but it's a different one. And let's also take another look at the schematics. Motor with chain, motor with chain. This comes from port 7 and from port 6. Alright. Here. Where is port 7 and where is port 6? Port 6 is here, which has output value 1, which was exactly the same as with the other one. The other motor, now there are two motors with chain and they are the same version, they are the same model. They both work. Okay, that is, let's see again, 6 and 7. 6 and 7. So where is 7? This is the right 7. Oh wait, this is directly on the port. While I have here analog out pin. Oh wait, that's a nice one. Oh, out pin 7. And out, wait, if I do that here, I'm using, this is the right 7. Wait. This is the right. How can I do this the right on analog port? That is not making any sense. And that is what I'm doing. Digital right to port 7, 9 and 5. Really. Out pin. Where's 7, 9 and 5? is an analog in pin, out pin 7, out pin 5, 9 is an in pin. And by the way, wait, this should be, oh wait, this is all wrong by the way, because this should be an A9. Provided there is A9, yes there is, not connected but there is. And I've always used A for in, not for out. How did that happen? Also, how have, yeah, pin mode 9 input. Oh dear. And yet here I'm writing it as output. Looking at wiring, it is being dealt with as input indeed. Alright. This means that my code is kind of a mess up, mix up, whatever. Yeah, how to deal with that one. How to make sure that that motor starts running. The signal is now and I'm talking about this signal, is now half. It's 50%, half speed. Which makes me wonder what the other one is. Yeah, that's full speed. Alright. So this one, mind the camera, and going here. So this one gets its signal from here, which gets its signal from here, which goes straight to 7. And 7 is denoted as out pin, analog out. And that's where the confusion started. Out pin, right, is the same thing, this one. And output value 1. And where did I write output value 1? Somewhere here, output value 1. So pin 7 has actually the same output as pin 6, which we can see here. Pin 6 is 253, which means pin 7 is 253. Oh, I already have it. Yeah. Making the whole thing as why does it do it? Makes no sense. Making absolutely no sense. So if I change the wire from here to right, that works. Oh, that reminds me, I did it once before with the same effect. But then it was with these two motors. So I have this problem. So Y on pin 7 is a yes, Y on pin 4 is a no. Pin 4, hold on, pin 4 says 126. Hold on, wait a moment. Yes, it is 4, is output value 2. Output value 2 is half. I am putting it back to 1. And it is clear, of course, that 126 is the half of 255. So that is clear. Let's just do it. Seven one five one 7152 kill. Upload. Done. Go. That one runs using the input for the chain motor. Now once again where it should be connected, and where I for some reason can't connect. So let's be a bit careful. Right, let's probe right here. Right here. It has the full signal. And I have to be a bit careful with components. Alright. But here I have a very different signal than I have right. Oh no, it's not a different signal, it's the full signal. Just a little bit different. So what if I remove the inductor? And that will be the last thing for this time. What if I remove the inductor? Alright, a very short one. I only moved a short wire between the inductor and the transistor straight to the resistor. So in schematics, where am I? I'm here. So what I did is move this wire, right here, straight here. So I'm skipping this inductor. And it made no difference. So if I look here, it makes no difference at all. Which I don't like, but it is what it is. And with that, I end this episode. So once again, examining the code and do wiring experiments to get this motor working, which hasn't succeeded, unfortunately. And here a little wire that I just moved one hole, but yeah, to no avail, unfortunately. Although the power controller clearly showed that that worked, so it must be something else. Thank you for watching. If you like this video, please subscribe to my channel, give the video a thumbs up, leave a comment if you like. You can also follow me on Twitter. Please retweet, like and leave a comment. You can also follow me on Instagram. Please like and leave a comment. Please show your support by making a small donation. You can also become a patron and have your name mentioned on my website and with my videos. Once again, thank you for watching. Bye bye.